All right, so some of us are still having some trouble with how to balance our reactions. So I wanted to put out a video there, show you how to do this one more time. And I think we all did it in class, but some of you might have not been there that day or whatever. But so we get to see it one more time. Okay, so you're sitting with a reaction in front of you. The first thing we're going to do is to go through both sides. The idea is to have the same number of elements, same number of atoms on the reactant side that we end up with on the product side. So we want to go through both sides of the reactions, list the elements. So on this side, we have a calcium atom, and we have some hydrogen, and we have some oxygen. Okay, we should have the same things over here. We have some calcium, we have hydrogen, it's in two different places, so we're going to keep an eye on that, but we also have some oxygen. If you don't have the same elements on both sides, go back, you probably did something wrong. Calcium here, and hydrogen, and oxygen. Now I encourage you just make one list on each side. Don't write calcium and oxygen and hydrogen here, and then hydrogen over here too. One list on each side and put them in the same order. You will be happiest. Okay, now we count. On this side, I have one single calcium atom, and I have two hydrogen atoms, and I have one oxygen atom. Okay. On my product side, I again have one calcium atom, and I have two hydrogen because I have an OH group, and each of those have one, but I've got two of those. So that's two hydrogen here, plus there's two hydrogen over here. So that's a total of 4 hydrogen that I have on that product side. And then I have 2 oxygen atoms. Okay. And then we look for things we can fix. Think multiplication, not addition. Never think division. Division is not going to solve very many of our problems. Think multiplication. What can I multiply over here that will get me the same things so they match over here? So I've got a 1 here and a 2 here. We always need to get bigger. Don't try to make the 2 turn into a 4. Think the 4 needs to turn into a 2. Okay, so I know that if I take this 2 and I multiply it by 2, I should get 4 hydrogen like I've got here. So I'm going to multiply by putting a coefficient, just like in math. Oops, fix that there. Just like in math, when you scratch paper here, I have like a 2x. It means I have 2 times x, right? Okay, so we're going to put some coefficients in front of these to make them match over here. So let's get rid of that. Okay. We said we needed to multiply this by 2, so I'm going to put a 2 way out here in front. I cannot change this 2. I cannot change this 1. I can't put any numbers in the middle here. The only place I can put anything is right there. So now, if I have 2 water molecules, that means I have 4 hydrogen atoms and 2 oxygen atoms. And if you need that drawn out, see, like, right? If I've got 1 water molecule, this is an oxygen and 2 little hydrogens on it, and then like another water molecule. Okay, 2 water molecules will leave me with 1, 2, 3, 4 little hydrogens and 2 big fat oxygens. Okay, and that should do it. Now, if you are filling out one of my Google Forms, you need to be careful because you're going to check the box that says 2 underneath the water, but you also need to check the box that says 1 under calcium and the calcium hydroxide and the hydrogen, because that's the only way we could make the system happy. Okay, so that's how it works. I'm going to do one more. This is a fairly simple one. Actually, I'm going to do 2 more for you. Okay. Sometimes we run into situations like, let's say, I might have a barium nitrate plus, so I'm going to run out of room if I'm not careful, a sodium sulfate that turns into a barium sulfate plus sodium, whoops, all right, I know, I have an eraser, plus, I'm sorry that, yeah, I have to write here, plus sodium nitrate. Okay. Now, I could list all the elements that I've got underneath this, but there's a lot of right here, isn't there? There's a lot of oxygen in this compound, and I don't want to have to try to count up the number of oxygen atoms on both sides and keep them straight, and this is just really annoying. So what I'm going to do is, you notice that this nitrate is an NO3 over here, and it's still an NO3 over here. Now, if you've seen my one on reaction types already, you'll see this is a double displacement reaction, and all that this does is it takes my ions and just kind of shuffles them around a little bit, and it never changes what those ions are. So this NO3 is an ion and this SO4 is an ion, and they stay together as a group. So we're going to treat them just like they were elements, and I'm going to say that I have barium and I have nitrate ions and I have sodium and I have sulfate ions. Now I did the same things on my product side. Barium and nitrate and sodium and sulfate. Okay, and we count. I have just one barium atom and I have 2 nitrate ions and I have 2 sodium ions and I have 1 sulfate ion. Well, what about, there's a 4 here, right, but there's a 4 here too. So I have 1 of these SO4s. If there's going to be more than one of these, if you're going to do this, it will always have parentheses like that. Okay, so the same thing over here. I have 1 barium, and again, just 1 nitrate, and 1 sodium, and 1 sulfate. And again, we look for what can I multiply that will make the 2 lists match. Well, if I multiply these 2 by 2, then they match over there. All I have to do is put a 2, move the plus over a little bit, right there. If I had 2 sodium nitrate formula units, then I would have 2 sodium atoms and 2 nitrate groups, and that would match the way I need it to, right? Usually pretty straightforward. So one more, probably the toughest kind to balance, and really it's just a little bit of back and forth that we have to do. Okay, hardest ones to balance, the ones that are going to have the biggest numbers. If I had a C for H10 plus O2, and that produces CO2 plus H2O. Now again, if you've already learned about the types of reactions that we've been looking at the last couple of days, or I suppose just today, if you've already seen that, you'll notice that this one right here, this is going to be a combustion reaction. Okay. Generally, anytime we have a C and H compound, sometimes there's an O that reacts with oxygen, you're going to get carbon dioxide, you're going to get water. This is a combustion reaction. Okay, and you'll notice when we go to list these out that I have carbon, I have hydrogen, and I have oxygen, and they're exactly the same thing over here. Any reaction where these are your elements and that's only your elements, it's combustion. So how many do we have? They're usually pretty simple. There's 4, there's 10, and there's 2. Well, that was easy, right? There's 1 here, there's 2 there, and you'll see there's 2 oxygen in this compound and 1 oxygen in that compound for a total on this side of 3. Okay, you'll notice that this time we're going to have to do some more multiplication. It's not going to simply be a 1 number and we're done. Start with the carbon, always. When you have this kind of reaction, always start with the carbon. In order to get them the same, I need to take this times 4, which means I need to multiply this compound up here times 4. So now I have 4 carbon. Well, now I have more than my 3 oxygen, but we're going to count those up in a minute because it's going to change on us anyway. I need to have 10 hydrogen, and I only have 2, which means I need 5 times as many, right? 10 times 5, so we're going to put a 5 here, and that changes my hydrogen to a 10. Great. Now let's count our oxygens. 4 times 2, if I have 4 carbon dioxide molecules, and there's 2 oxygen in each, I've got 8 oxygen here, and then I have 5 water molecules times 1, so that's 5 there. 8 plus 5 is going to give me 13. So what can I multiply my 2 by to get 13? first thought, we have nothing that's not going to work, and we panic just a little bit. And then we take a deep breath. And we know that you all been through grade school. You know that we could multiply it by 6.5. Well, that seems silly. Can we have a half of an oxygen molecule? No, you can't. But for just a second, I'm going to write that 6.5 right here. Okay. But I know I can't leave it. So what I have to do is multiply everything across the whole reaction by 2. So I'm going to change this, what was a 1, to a 2. And the 6.5, we're going to change to a 13. Well, now my fraction's gone. And then I'm going to change my 4 to an 8. And my 5 to a 10. Now, if we go back and we add again, we now have 8 carbon and 20 hydrogen and 26 oxygen over there. And then I have 8 carbon and 20 hydrogen. And there's 16 here. We'll keep track of that here. 16 oxygens here, 10 there. Gives me a total of 26. We'll get rid of those. Okay. And that'll give me the number I need. Another thing you can do, instead of even bothering to ever write this fraction in, if you're going to need a 6.5 or a 3.5 or a something and a half, just don't do anything with it. Come back and put a 2 here and double those two numbers and then figure out what you're going to need there. Okay, I hope that helps.